Write all possible resonance structures. And here I am showing you three main patterns to draw our resonance structures, which is a double bond next to a positive charge, a double bond next to a lone pair, and a lone pair next to a positive charge. So what we're going to do is we're going to try to recognize one of these resonance patterns in our molecule and learn how to draw the correct curved arrows and how to show the other resonance forms. The first thing that we need to do is we need to realize that lone pairs of electrons are missing on our molecule. Oxygen and nitrogen want to have 8 electrons. They want to have an octet, but lone pairs of electrons are not shown, and that's what we will do first. Now remember that oxygen here, it has 2 bonds, and every bond has 2 electrons. That means it has 4 electrons, but it wants to have 8. So let's give it 4 more electrons, or 2 lone pairs of electrons. Nitrogen has 1, 2, 3 bonds, which means it has 6 electrons, but it wants to have 8. I need to show 2 more. Now that I'm done with showing my lone pairs, I can go ahead and look for patterns. So here I notice that I have a lone pair next to a double bond lone pair of electrons, single bond, double bond. And that's exactly one of my patterns, which is a double bond next to a lone pair. A double bond, single, and a lone pair of electrons. For this resonance pattern, what I will do is I will draw 2 arrows from the lone pair to the single bond to create a double bond, and then we will take electrons away from this carbon to put it on the lone pair on this adjacent carbon to make our lone pair. Let's go ahead and follow this. So our resonance curved arrow will start from the lone pair to the single bond, and that creates a double bond here. And that means this carbon will have too many bonds, because remember that row 2 elements cannot have more than 8 electrons. This carbon would otherwise have more than 8 electrons. So we need to take some electrons away, and we can put it on the oxygen. Let me just put it here. And for resonance, we show double-headed arrows, and let's see what our resonance form will be. So here I have a nitrogen, and I used its electrons to make a double bond here. It will have a positive charge because it's now sharing its electrons. And now I have an oxygen, and instead of 2 lone pairs of electrons, I will have another lone pair, and that came from this double bond, giving these 2 electrons, giving the electrons to the oxygen, and it will have a negative charge. So that's my first resonance structure. And by the way, these are not the only patterns, these are not the only resonance patterns that we have, but these are just some of the main ones that we see most often. And this is just to help you figure out how to start your problem, what to look for. So let's go ahead and look at number 2. Again, the first thing we do is we need to add lone pairs. Oxygen has 2 bonds, which means it has 4 electrons. So we need to add 4 more to give it 8 electrons. This oxygen also has 2 bonds, so it also needs 4 more electrons. And what kind of pattern do I see here? Again, similarly to question number 1, I see a lone pair, single, double bond, lone pair, single, double bond. So that's my pattern. I'm going to go ahead and use one of the lone pairs of electrons to make a double bond here, and then I will take away one of the double bonds and make a lone pair here, and let's see what we will create. So let's redraw our molecule. I have an oxygen here, and my oxygen now has a double bond, and one lone pair is left here. Now my oxygen here used to have a double bond, but now it will have a single bond because I used the second bond to give electrons, to give an extra lone pair here. So now we will have 6 electrons around this oxygen. In terms of charge, this was neutral, but now it's sharing its electrons, so it will have a positive charge. And this was neutral, but now it's going to get more electrons. Remember, electrons are negative, so it will have a negative charge. And if you're not sure about formal charges, you can watch my formal charge video, because you can easily calculate the formal charge also if you're not sure. Over time it will become intuitive. And let's go to my problem number 3. Again, for this oxygen, I must show the lone pairs. It has 2 bonds, which means it has 4 electrons, and that means 4 electrons were not shown, and I'm showing them here. What kind of pattern do I have here? Notice I don't have a lone pair next to a double bond, so that can be it. I also don't have double bond next to a positive charge, because there's no double bond here. I do have, however, a lone pair next to a positive charge. So I have a lone pair next to a positive charge, and what we can do here is we can just use our electrons from the lone pair to share it with the carbon that has the positive charge, like so. And actually, I'm realizing that my example here is the same as here, so we already know what the answer is. And let's go ahead and go through it. So that means 1 lone pair is left. This lone pair was used to make a bond here. Now this carbon was positively charged because it didn't have enough electrons, but oxygen is sharing its electrons with the carbon, so now carbon is happy and neutral. Oxygen was neutral, but now it's sharing its electrons. It's giving its electrons to share with the carbon, so it will have a positive charge. Now let's say you're not sure how to figure out the formal charge. I'm going to show you right away. To figure out the formal charge, you can just think about how many valence electrons does your oxygen have. Oxygen has 6 valence electrons because it's in group 6, minus how many bonds is it attached to. This oxygen is attached to 3 bonds, plus how many lone electrons does it have? 2. So 6 minus 5 is equal to +1. That's why it has a +1 charge. So that's another way for you to do formal charges if you're not sure. And again, you can look at my formal charge video to see how to have more practice and to see how to do formal charges more. This is Maya Loach, and I hope to see you soon.